Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 4 in the CSRF module titled CSRF where token is not tied to user session. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, go down, select the learning path, go down, select CSRF, which is the module we're working with, and then go down to lab number 4, titled CSRF where token is not tied to user session. All right, let's get started. This lab's email change functionality is vulnerable to CSRF. So we've got a vulnerable parameter over here is the email change functionality similar to the previous lab. It uses tokens to try to prevent CSRF attacks, but they aren't integrated into the site's session handling system. Okay, so it does have some kind of defense against CSRF, however, it's implemented incorrectly and therefore still vulnerable. To solve the lab, use your exploit server to host an HTML page that uses a CSRF attack to change the viewer's email address. So the goal of this exercise is to exploit the CSRF vulnerability to change the email address of the viewer or the user that we're attacking. You have 2 accounts on the application that you can use to help design your attack. The credentials are as follows. So the first credentials over here are similar to the previous lab, so we have them written. And then we've got the second credentials, so Carlos and Montoya, if I'm saying that correctly. All right, so let's access the lab. And while that opens up, we'll open up Burp Suite Professional. So for the first part of the video, we'll solve the exercise using Burp Suite Professional. In the second part of the video, we'll only use the community edition and script the exploit on our own. So stick around if you don't have the professional version of Burp. So let's close this, hit next, and then start Burp. Okay, let's go back to our browser. The first thing we're going to do is log into the application using the credentials that we were given. So we're going to assume that this is the user we want to phish or attack. Hit login. And here's the email change functionality that we've been dealing with in the previous labs. Now let's set our browser to send requests to Burp and change the email to test.test.ca and hit update email. And here we go. So it intercepted the request in proxy. I'm going to send this to repeater and then send another one to repeater because we're going to use it multiple times. So turn intercept to off and we're going to be working from repeater from now on. All right, so in the previous labs, we talked about 3 conditions that have to be satisfied in order for a CSRF attack to be successful. The first one is you have to have a relevant action. In this case, it's the same action as previous labs, so it's a change email functionality. And the reason it's relevant is because if the attacker has control of changing this email address, it would have detrimental effects on the client. So in this scenario, as an attacker, if I'm able to phish you and get you to change your email address to one that I own, then I could use that email address that I control in order to change the password of your account and fully compromise your account. So this is definitely a relevant action, so this checks off. The next one is you have to have purely cookie-based session handling, which is true for this case as well. Session management is handled using one cookie called session, and this is the value of the cookie. And the third condition is no unpredictable request parameters. Because this is a pre-made request that the user would have to click on, we have to know all the parameters that make the request successful. So in this case, we know the email parameter. It's one that we want to change to our own email. The second request parameter, though, is unpredictable. So you've got over here a random token, and the attacker has no way of figuring out what that token is going to be beforehand. So at first glance, this seems to be not satisfied, which makes the CSRF attack not possible. However, depending on the implementation of how CSRF tokens are generated or how they're implemented and integrated in the application, it might still be vulnerable. So let's perform some test cases. In the past two labs, we started talking about our methodology of testing CSRF defenses. The first one is remove the CSRF token and see if the application accepts the request without the CSRF token. So let's remove that and see if the application accepts the request. And it doesn't. So it says missing parameter CSRF. So let's go back. The next thing to test is see if we can change the request method from post to get. So we're going to do that. To do that, right click, change request method, and it changed it to get. Let's hit send. And it says not found. So it doesn't allow us to change the request method from post to get. If it did allow us, the next thing we would do is check if the get method requires a CSRF token, because most applications don't use CSRF tokens for get methods and only use them for post methods. All right, so that looks good as well. There's one more thing I want to check, and let's try and go back to our CSRF token, and it doesn't let us, and that's why I sent a couple of requests to repeater. And I'm going to send this one again, just in case, and work with the second one. So the next thing I'm going to check is see if it actually requires a valid token. So I'm going to change this to J and see if it accepts it, and it doesn't. So it says it's an invalid CSRF token. So this token value is definitely checked in the backend. All right, so the third thing to check is see if CSRF token is tied to user session. So a correct implementation of a CSRF token requires that this CSRF token over here be tied to this session over here. This is how it can tell that this CSRF token was generated for this user account. And so to test this, we do need another account on the application. And in a real world scenario, the way you would get that account is either if you're already a member of the application or if the application has a sign-up functionality. In this case, we're already given an account in the application. So we're going to assume this is the attacker's account and this is the victim's account. So to log into this, we're going to go back to Firefox and open a private session. So I'm going to have to re-log in. So I'm going to log in, access the exercise. So I'll do that and we'll come back to the video. And we're back. So again, I'm in incognito mode and I've logged into Carlos's account. So what we need to do over here is right click, inspect element, and obtain the CSRF token over here. So I'm going to copy that and check if it works with the victim user's account. If it does, that means the CSRF token is not tied to the session ID of the account. So let's paste this and hit send. And here we go. So if we follow redirection, you could see that the email address was changed to test@test.ca. So this is satisfied. The third condition, which we weren't sure is satisfied because CSRF token is not tied to user session. All right, so this is vulnerable to CSRF. Now the next thing to do is get a working exploit. And again, with Burp Suite Professional, there's a really easy way of doing that. You just right click, click on Engagement Tools, and then generate CSRF POC. And it generates the HTML document for you. The first thing we want to do is click on Options, and then select Include Auto Submit Script, and then click Regenerate. And you could see over here, it created the HTML document. So you've got the form element, which changes the email address. It's a post method. It has two input values. One is the email, which should be the email address of our attacker. So let's say test2@test.ca. And the second one is the CSRF token. So we need to get the CSRF token of our attacker and put it in here. So let's go to our attacker's account, which is Carlos. Let's reload it again because I can't tell if CSRF tokens are generated each time. So they are. So it changes with every request. So let's copy this, put it in here and paste it. And then we've got the submit button and this auto submits the script. All right, so let's copy HTML and test it on our victim user's account. So we go back to our original Firefox session, we go to exploit server, and we put our script in the body. So what the exploit server is doing is it's hosting our script. The first thing we're going to do is store the exploit, and then we're going to deliver the exploit to the victim user. And here we go. It says, congratulations, you solved the lab. If you want to see if the email address was changed, click on view exploit. It should automatically submit. And it says invalid CSRF token over here. And the reason it does that is because it already submitted it. And the CSRF token is no longer valid anymore because it's only used one time and it's already been used. But if we go back to the application, we should see that it changed too. And it did not, because it's doing it on another session. So that's fine. What we're going to do is redo this. And we need a new CSRF token for this because, again, it's changed every time. So let's copy our new token, put it in here, paste it, say copy HTML. And if we could go back to our exploit server. Oh, we're in the wrong one. So let's go back to our exploit server, and it's not letting us. Okay, so because the exploit server is no longer there, since we've completed the exercise, what we're going to do is test it in the browser. So click copy and put it in here. What that does is instead of it being hosted using the exploit server, it's now hosted on Burp Suite. So you could see that over here. So hit enter. It should automatically submit, and here we go. You see that the email address changed to test2@test.ca. So we've definitely completed the exercise using Burp Suite Professional. Now let's script it with our own exploit and host it on our own server. Before we do that, we save. And we put our notes in the wrong document, so I'm going to copy that and paste it in notes, save that, and remove this over here. So this is an HTML document. It's supposed to host our script. So let's close this. We no longer need the professional version of Burp. Instead, what we're going to do is we're going to assume that we're using the community edition and not use any features that are provided by the professional version. Okay, so if you're using the community edition, all you have to do is intercept the request first in proxy, send it to repeater, and then work from there. So the first thing we do in our script, as usual, we start off with an HTML element, and then we create a body element and a heading element. So this is what the user is going to see on the page. In a real life scenario, you want to include much more than that so that the user doesn't know that this is a malicious email or a malicious website. All right, the next thing we want to do is the form element. And we're going to add the action attribute. And the action over here is going to change the email address. So we're going to copy this, put it in here, add HTTPS, and add the path to change the email address. The next thing I'm going to do is add the method, which is post. Because you could see over here, this is a post request. And then I'm going to add an ID to my form element because I might need to reference it later. And we're going to call it CSRF form. All right, that looks good. The next thing to do is add the input elements in the form. So we'll start off by adding the email, and we'll say the type is equal to hidden because we don't want the user to see what we're doing. The name would be equal to email, and the value would be equal to, let's say, test5@test.ca. And then we have another input vector, and that's the CSRF token. Again, it's hidden. The name is equal to CSRF, and the value would be equal to the value of the attacker's CSRF token. So we're going to go back to the incognito mode and reload this. And again, we need to reload it because the CSRF token changes every time. So let's inspect element and copy it from over here. So that's the CSRF token of the attacker. And let's paste it. That looks good. And then we need to submit the request when the page is loaded. So we're going to add a script tag or a script element, say document.get element by ID. And the element we want to get is the form element. So the ID of that is CSRF form. And I'm going to hit submit. And what that does is when the page is loaded, it automatically submits the form for us. Now, we don't want the user to know that we're doing this action over here. And so what we're going to do is we're going to submit this form in an invisible iframe. So we'll use the iframe element. We'll say the style is equal to display none, and the name is equal to CSRF iframe. All right, and we need to add a target over here in the form element saying that it should be submitted through the iframe. So CSRF and iframe. So the name of our iframe element, and click save. So this looks good. The next thing we need to do is host our script on a web server. So to do that, I'm going to click on terminal, new terminal, and then I'm going to start up a simple Python server. So that's the syntax for it in Python 2. It will be different in Python 3. And what's left is to host the script. So we're going to go back to our original session. So if we reload it again, you could see the email address is test2@test.ca. And then we're going to send the victim user this link over here with the name of the script. So it was CSRF Lab 04.html. And we're going to tell the user, hey, check out this really cool website. The user is going to click on the website. He'll see that there's hello world and have no idea that in the background we changed his or her email. So let's see if the email got changed. And it did. Here we go. So we changed the user's email without the user even knowing it happened. All the user sees is hello world, and in the background it changed his or her email. All right, so we successfully completed the exercise by first exploiting the vulnerability using Burp Suite Professional and then manually scripting it on our own.